will be doing a series of experiments to find out which structure will corrode faster, the Taj Mahal or the Colosseum.
Three factors will be explored upon by us: concentration, temperature, and surface area.
We will be investigating the environment and the structure of the two structures and converting our findings into replacement materials and a setup to imitate the acid rain, the main source of corrosion.
From there, we will explain our new results with prior knowledge from previous chemistry lessons and come up with a final conclusion that answers our main question. Acid rain is first created when factories and cars emit SO2 and NO into the air. These two chemicals then react with the rain and create acidic rain. Acidic rain, when in contact with CaCO3, which is what both the Colosseum and Taj Mahal are made of, it reacts and starts corroding the structure. So today, in order to find out which of the two structures will have a higher rate of corrosion, I will be attempting to use the acidity of rain. Here's a short animation to show how acid rain is formed. According to my research, in the area of Taj Mahal is located, Uttar Pradesh, the amount of factories located there are a lot more than that in Rome. From my research, I also know that the amount of cars within Rome is 1.7 million, and in Uttar Pradesh, there is approximately 23.94 million cars. This all goes to show that the amount of pollution in Uttar Pradesh is a lot more compared to Rome. Since it had already been scientifically proven that with the increase of acidity of a certain acid, the rate of reaction would indeed be higher. Therefore, our hypothesis is that the Taj Mahal structure will corrode faster. As such, in order to replicate this experiment, we have replaced the materials for building the structure with eggshells instead, as both of them have a similar chemical formula of CaCO3. Then we replace the acid rain with vinegar instead. By doing so, we have effectively replicated the real thing. In order to record the rate of corrosion, I have decided to use the method of displacement of water. This method allows us to find out the rate of corrosion of the eggshells by finding the carbon dioxide produced when a reaction occurs. Through my pre-calculations, I found out that 5.5 gram is the average weight of an eggshell, and 95% of it is CaCO3. So with the knowledge, we discovered that 30 ml of vinegar would perfectly submerge all of the crushed eggshells. Due to time constraints, we were only able to use 5 minutes for each of the experiment, and in each minute we recorded the amount of CO2 made. Using collision theory, the rate of reaction/corrosion is increased due to the increase of acidity of rain. This is so because with the increased acidity in the same volume, the amount of reactant particles are also increased, and therefore there's a higher frequency of collision between the particles and the acid, and with that the higher frequency of collision, effective collision. This therefore increases the rate of corrosion. Thus, my conclusion is that the Taj Mahal would corrode first.
Investigating is the temperature in the country. Through my research on the temperature of Uttar Pradesh, India, and Rome, Italy, I decided to use the city's highest and lowest temperature as a gauge to be used in the investigation. I found out that the highest temperature of Uttar Pradesh is 40 degrees and the lowest temperature there is 8 degrees, while the highest temperature of Rome is 32 degrees and the lowest temperature there is 3 degrees. We'll be using the difference between the hot temperature of both cities and the difference between the coolest temperature of both cities in our investigation. Since we all know that the higher the temperature, the faster the rate of reaction, thus concluding on a hypothesis that Taj Mahal will corrode faster under the temperature factor. As such, we will be using the eggshell and vinegar reaction to investigate further. I'll be using displacement of water method to collect the CO2 gas produced to find the rate of reaction. I made pre-calculations to find the theoretical volume of CO2 that should be produced. I decided to use 5.5 grams of eggshell in each setup, as based on the internet, 5.5 gram is the average weight of each eggshell, and it contains about 5.17 grams of calcium carbonate. Thus, for easy calculation, 30 ml of 5% acetic acid vinegar was added so that all the 5.5 grams of eggshell can be crushed and submerged in the 30 ml vinegar, which has about 1.5 grams of ethanoic acid. By using this volume to find the mole, I managed to find the theoretical mass of the CO2 produced, which is 0.30 dm3. Due to time constraint, only 5 minutes were given for each setup. Thus, it was not as accurate as it did not show the full reaction. The volume of CO2 produced was recorded every minute until 5 minutes. And also due to time constraint, I was only able to use the highest temperature of both cities in the experiment. By cooling the vinegar that was supposed to stimulate the cooler region based on the difference between the highest temperature of both places. Here are my results. From the results, we can conclude which eggshell reacted faster through the volume of CO2 collected. Now is my explanation for the results. The rate of reaction increases as the temperature increases. The Indian setup vinegar has a higher temperature. Thus, the reactant particles, which are the H plus and the CO32- ions, have more kinetic energy, thus moving faster and colliding more often, therefore increasing frequency of collision and increasing frequency of effective collision of the reactant particles. For the Italy setup, the vinegar has a lower temperature than that in the India setup. Thus, the reactant particles will not have as much kinetic energy and it will not move as fast as the one in India, and the frequency of collision of the reactant particles will not be as high. The frequency of effective collision will therefore also not be as high of that in the India setup. Thus, we can conclude that Taj Mahal will grow faster based on the factor temperature.
The factor that I am investigating is the surface area of the structures. From online research, the Colosseum takes up an area of 24,000 meters square and weighs 997,903,214 kg, while the Taj Mahal takes up an area of 170,000 meters square and weighs 2,500 trillion kilograms. Assuming rain only falls directly on the area facing towards the sky. From this data, we can find out the surface area to weight ratio of the structures, which we can use to simulate corrosion of the structures in an experiment using props. We found that the Colosseum has a larger surface area to weight ratio of 0.2410 cm square per kg compared to the Taj Mahal's 6.8 times 10 to the power of -7 cm square per kg. In order to simulate this difference in surface area in the lab, we used an egg broken into half and an egg broken into many smaller pieces as replacements for the Taj Mahal and Colosseum respectively. We then carry out the experiment where we use displacement of water to collect the CO2 from the experiment as a means to find out the rate of reaction of both specimens, using vinegar as a replacement for acid rain and eggshells to imitate the building material of the structures. First, we place the eggshells of both surface areas into separate flasks and submerge the eggshells with an equal volume of vinegar. From the same bottle at the room temperature, we connected the flask into the measuring cylinder and collected the carbon dioxide gas formed from the reaction between the acetic acid and the calcium carbonate present in the vinegar and eggshells respectively. We then timed the experiment for 15 minutes. After trying the experiment 2 times for each specimen of eggshell, we found that the setup with the eggshells or smaller pieces simulating the Colosseum yielded more carbon dioxide than the eggshell broken into half. From the results, we can also say that the reaction rate of the smaller eggshells and the vinegar is faster than half the eggshells. This is due to the difference in surface area. When an eggshell has a larger surface area, only the outer surface that is exposed to can react with the acetic acid. If the eggshell is separated, there is more surface area exposed to the acid, causing more frequent collisions between the reactants, leading to a higher frequency of effective collisions that actually cause the formation of the CO2 gas we collected. Hence, from our results, we can conclude that the Colosseum, due to its surface area, is able to corrode faster than the Taj Mahal. After all the experiments, the Taj Mahal was proven to corrode faster due to Uttar Pradesh's more concentrated acid rain and high room temperature compared to Rome.
However, the Colosseum was proven to corrode faster if surface area was the only variable taken into consideration.
In conclusion, since the Taj Mahal would corrode faster when 2 out of 3 of our factors were changed, we have decided that the Taj Mahal will in fact corrode faster.